Hello students! Today let us start with new chapter probability. In our everyday life, we usually come across statements such as most probably it will rain today. I doubt that Rahul will pass the test. Chances are high that the prices of diesel will go up. There is a 50-50 possibility of India winning toss in today's match. In our examples, occurrence of rain, passing of Rahul, price rise for diesel and India winning match are all events. And can you guess the outcomes of all these events? To do it, pause the video, take a second and think about the outcomes. Yes, you got it right. We cannot say about the outcomes of these events with confidence, since we are not sure that these events will definitely occur. It is just what we feel about the outcome for that particular event. The words doubt, most probably, chances, etc. used in the statements above involve chances of event to occur and maybe not to occur. So we cannot talk about the outcomes of these events with confidence. Like in our first example, it might rain and might not rain today. In second example, Rahul can pass, but he can also fail. In third example, diesel prices might go up or might not go up and remain the same. In the last example, India might win, might it lose the match. So these words doubt, most probably, chances, etc. show the chances of occurrence of this event and chances of this event not occurring. But what if we could measure the amount of these chances numerically? So students, this we have talked about chances of event occurring. But in maths, what if we could measure the amount of such chances numerically? Yes, this numerical value gives the likelihood of any event to occur. And this likelihood is nothing but the probability that we calculate. Say in example 1, when we say probably rain might occur, the likelihood of rain coming is not very likely, which means that we exactly are not sure about it in percentages or in numbers. We are just predicting about it. It may rain or may not rain today. Similarly, in case 2, the likelihood of Rahul passing the test is very low. In case 3, the increase in prices of diesel is very likely. And in case 4, likelihood of India winning is somewhere in between, the very likely and not very likely. Thus we can say that probability of any event tells us how likely it is for an event to occur numerically. For example, during tossing a coin 1,000 times, the frequency of getting heads is 455 and that of getting tails is 545. Can we calculate the probability of each outcome? Yes, you heard it right. I said each outcome. Since during tossing a coin, getting heads is one outcome and getting tails is the other outcome. So can we calculate the probability of each outcome? Pause the video, take a second and give it a shot, because you have already learned how to calculate probability in your previous standards. Here, when we toss a coin, it is event of our experiment that we are doing. When we toss the coin, either heads can come or tails can come. So heads and tails are the two outcomes of our event. Now in the question, we are given that when we toss a coin for 1,000 times, head comes 455 times and tails comes 545 times. Now from our previous standards, we know the formula to calculate probability of any event. It is number of outcomes in that event upon number of times that event occurred. So here we know that tossing a coin is one event and there are two outcomes here. One is heads and second is tails. So in our experiment, an event occurred for totally 1000 times, since we tossed coin for 1000 times. And outcome heads was 455 times and outcome tails occurred for 545 times. Thus, probability of heads is 455 upon 1000, that is 0.45, and probability of getting tails is 545 upon 1000, that is 0.545. Students, we need to remember here that these probabilities are only estimates for one set of event or experiment. If we perform the same experiment, that is, if we toss a coin, say for another 1000 times, we may get different data in the second experiment, and it will give us different probability estimates. So we can say that with each experiment, the probability of outcome changes. Now observe that these probabilities are based on the results of an actual experiment that we did. That is, we actually tossed a coin 1000 times and recorded the data. For this reason, they are called as experimental or empirical probabilities. We can say that experimental probabilities are based on the results of actual experiments and adequate recordings of the happening events in that experiment. Now, students, when we carry out experiments in science repeatedly under identical conditions, we get almost the same result. Such experiments are known as deterministic experiments. For example, the experiment to verify Archimedes' principle or to verify Ohm's law are deterministic experiments. Every time we will perform this experiment, their outcomes are fixed and hence can be predicted well in advance. But there are certain experiments in which the outcomes may be different even when performed under identical conditions. For example, when a dice is rolled, a coin is flipped, or while selecting balls from the box. In such cases, we cannot predict the exact outcome of these experiments. Such experiments are called as random experiments. Each performance of a random experiment is called a trial, and the result of each trial is called an outcome. So remember clearly, when one experiment is performed for many times under identical conditions, that is, we have many trials. In that case, if all outcomes are same every time, that is, result of every trial is same, such experiments are called deterministic experiments. And if outcomes are different every time, then such experiments are called random experiments. Now, how to calculate probability of such random experiments, we will see in our next video.